This is Mr. Gillum, and today we're going to talk about scatter plots and lines of best fit. Okay. This is an example of a scatter plot. It displays two sets of related data on the same set of axes. The points are not connected. Okay. Yesterday we plotted all of our points and then we connected each point with a line. Okay. Today it's just going to be a random assortment of points on a graph or on a chart. Okay. The points are not connected. There's different types of correlations, and correlation just means it's a pattern, okay? And in positive correlation, data on both the x and y axis increases. So, as you can see, the closer to 0 it is, the lower the values are, and as it gets farther away from 0 or bigger, it also gets higher on the graph. This is a positive correlation. A negative correlation decreases as the data goes on. Okay, as you can see, it starts at a higher point and it goes down the graph from left to right. You read a correlation just like you read a book. You read from left to right. If it's going downhill, it's a negative correlation. Finally, there's no correlation, where there's no pattern in the data. Okay, in this graph, there's just dots randomly spread out. There's no real, it doesn't really increase, it doesn't really decrease, so we're just going to call it no correlation. Okay, there's no pattern in the data. So now let's describe these correlations. Okay, do a few examples. In the top left corner, we have some points on a graph, and I'm just going to say that I can tell that as the chart goes on, the data is getting bigger and bigger and bigger. So as I start down here way low and I read it from left to right, it's getting bigger and bigger and bigger. I'm going to say that's a positive correlation. And let's look at the top right now. As you can see, the dots are starting at the top, and I'm reading it from left to right. Looks like it's going down, so I'm going to go ahead and say that's a negative correlation. And then finally, here's another example. We got just points just kind of scattered out. They're not really getting bigger. They're not really getting smaller. So we're just going to say that's no correlation. So let's look at a few more. Okay. As you can see, on the top left-hand corner, we're starting at the top, and we're going down as the graph goes across. So we're going to say the same negative correlation. And let's look at the top right-hand corner. Once again, we're starting at a higher point and we're going down from left to right. So we're going to call it a negative correlation. In the bottom left-hand corner, we have a graph that starts low, and as we go from left to right, it kind of increases or gets bigger. So we're going to call it a positive correlation. And then finally, we have this one down here, and there's actually points in all four quadrants. And there's not really a pattern because these ones up here could go like that. This could go that way too. We're going to say that's no correlation. There's no really pattern there. Okay, so let's just take a look at some of our stuff here. Okay, this is considered a line best fit. Okay, it's an estimate of the trend in data. So they're going to give you a graph with just the points on it, and we're just going to put a line through as many points as we can, or at least have as many above the line as below the line. We're going to do our best to do that. Okay, it's called the line best fit. You're actually going to make it yourself. Now, everyone's line might not be exactly the same, but it needs to be very close. Okay, so let's look at these graphs that we've already examined. We agree this is all positive correlation. I need to make a line that goes through as many points as I can make it go through, and it has to be straight, and there needs to at least be as many above as below. So that would be a line of best fit. Okay, and our lines are always continuous, so I'm going to go ahead and put arrows on it there. Okay, once again, I'm just going to try and draw through as many points as I can, as straight as I can, and that's going to be my line best fit. Okay, when you get to a no correlation, you're just going to put no line best fit, because there's really no line that's actually going to be a very good estimate for that. Let's look at a few more. Okay, this guy right here. Like I said, I want about as many points above as below the line. So I'm going to draw my line right through the middle there, as straight as I can. I'm going to call that the line best fit. As you can see, there's about as many above as below. There's 3 above, or 3 below, 3 above. Okay, about every other one. Let's go to the top right hand corner. This one's got a lot of points. I can still draw a line best fit though. Okay, there's a lot of points above, a lot of points below, about half and half. Then we're going to go over here to this guy in the bottom left hand corner and same idea. Just draw as straight as I can through there. And there's my line best fit. And then finally, we said we all agreed this is a no correlation. So if you get something like this where this line doesn't really make sense, this line doesn't really make sense, we're going to say no line best fit. Okay, so this is an exercise practicing our estimation skills, and we're estimating a line that fits the data. Okay, let's take a look at the scatter plot. It displays the number of home runs hit by baseball team members. And as you can see, the years are at the bottom, the number of years played, and the number of home runs hit are on the left column. And as you can see already, as you go on, as the years go on, the data increases. Okay, so that's something to think about. Okay, I want to know how many players are represented. So I need to go back to my scatter plot and I need to figure out how many players are represented. So looking at my scatter plot, I know that these are the years played at the bottom and the home runs hit are on the top or on the side column, but it doesn't really tell me how many players there are. So what I need to do is I need to count the points. There's a player, 2 players, 3 players, 4, 5, 6, 7, 8, 9, 10. There's 11 players here. So the number of points is the actual number of players. How many players are represented? I'm going to say there's 11 players represented. Okay. It also wants to know how many home runs did the player with 10 years of experience hit. So let's go back. And it says how many home runs did the player with 10 years of experience hit? So let's look. 10 years played is what we're looking for. We're going to know how many home runs did he hit. If we go up there and we find it, it's going to be, I'm going to say that's 200. 200 home runs were hit with a 10-year experienced player. So when it asks me that, I'm going to say 200 home runs. And then finally, it wants to know what is the range of the number of home runs. Now this is a tricky question. We know what range is. We've dealt with it before. Okay, we know that range is the highest number minus the smallest number. It's the highest number minus the smallest number. So let's figure out how many home runs were hit by the most home run hitter, by the oldest, or what is the highest number of home runs hit. I'm going to say it's right there. I'm going to estimate that to be 295. And I need to know what the lowest number of home runs hit. Right here by the 6-year guy, he only hit 50. To find the range, we take the biggest number minus the smallest number, and I'm going to say that must be 245. There's a range of 245 home runs. The range is 245. Okay, so we've answered all these questions just by looking at a scatter plot. So I'm going to go ahead and draw a scatter plot here, and similarly to the bar graph and the line graph, okay, I need an axis, a label, okay, as best I can, and I'm going to say, we're going to put our age down here at the bottom, and I'm going to put my price over here, and let's go ahead and start graphing. We have age from 2 all the way up to 9, so I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9 years, and then we have the price actually goes from, looks like my lowest is 25 all the way up to 150. So I'm just going to go ahead and count by 25s. 25, 50, 75, 100, 125, 150, 175, 200. So 200 at the top. Each one represents 25, oh, that should be just 50, 100, 150, okay, and so on. So let's go ahead and plot our points on here. Age 2, we're going 150. Okay, so I'm going to go over 2 and then up to 150. Right there. Okay, and then over 5 up to 105. 1, 2, 3, 4, 5 up to 105. All the way up to right about there. 845. 2, 3, 4, 5, 845. 495. 690. Go right up to about there. 390. 925. 90 should be up here. That's a mistake by me. 90 and 3 should be, 9 should be 90. 6 should be 90 as well. Should be right up there. Okay. I'm going to go ahead and erase those 2 points. Those are in the wrong spot. Okay. 925, we got that one. 2105. And 575. 2, 3, 4, 5. 75. And then 860. 6, 7, 8, and then 60, right about there. Okay. So that's what we're looking at for our scatter plot.